All right, folks. So if you don't know, this is a workshop on ML observability. And what's really great is we have a free public offering. So you can either get to it from the arize.com website. We have a short bit.ly link. The Arize team members are also going to be putting the link in the chat. So you'll be able to sign up for your free account. So just sign up for this because you'll be able to follow along with the hands-on workshop. And what's really great is after the workshop, you'll still have access to the platform. So you can even upload your own data, play around with it. I think it's a really great resource. Like I was seeing, who in the chat was, where people are from, what companies they're from. Because it's great for folks in industry that want to experiment with different ML observability tools. And it's also really great for folks in academia to get better understanding of how to actually handle models in production if they don't have the opportunity to actually push those models into production. So that link will continue to be shared. It's really easy to sign up. It's just like your name, email, you'll get a confirmation. And then we'll be able to walk through the workshop together. And again, you'll still have access to this platform. The way the workshop's structured is I'll do about 10 minutes of slides. And then the rest of the time is going to be in the demo. So it'll be part education and then like hands-on applications of the workshop. So hi, everyone. My name's Amber. I'm a machine learning engineer at Arize. Arize is an ML observability platform. And today we'll be walking you through on how to use the platform, how to use it for your use cases, and just the key pillars that really define ML observability. So on the agenda today, we're going to talk about challenges with productionalizing ML models, some of the key pillars of ML observability, and then applications of these in the Arize platform. So a lot of folks are attending this session today because we've seen the pains of trying to take a model from research to production. You could have something that looks great in your Jupyter environment, has perfect performance, all the benchmarks are met, you put it into production and all of a sudden things start to break. You realize you shouldn't have put that into production Friday night, and a lot of things could just happen. And it's really hard to pinpoint why a model is starting to degrade because oftentimes these models degrade slowly over time. These models fail silently. So we need to know when it's happening and how to fix it. In fact, a lot of teams find through a survey done by Arize that it takes over a week to actually detect and fix a model issue in production. So over 84% of teams say this. During that week, that's countless dollars. That's a huge portion of the KPIs that are really driving the business needs that just things aren't being met. If 84% of people say it takes over a week, but with ML observability, if it could take, a day or even just a few hours to resolve these issues, that's a huge ROI. So time spent on ML in the last 5 years, this was also from the survey we conducted of this is over 1,000 AI companies, machine learning engineers at all these different companies. They said that the time spent on ML in the last 5 years is majority on data prep, model training, and model development. Now, we can understand this because in order to even have models, you have to be doing data prep, model training, and model development. And then production's at the very end. And we actually saw that less than 1% of times actually spent in production during that machine learning pipeline lifecycle. And this is because the challenges that arise are very hard to tackle, and there's not really a set practice around it. But the common problems that plague all teams are around data and model drift, data quality issues, performance degradation, and then there's more and more things coming up around model interpretability, model readiness, and fairness and bias. And the reason this is so hard is that, machine learning, even though I would still consider it a pretty hot topic, it's been around for a while now that there's established tools and practices on, what are the best practices for actually data prep, model training, model development. What can we use and leverage to make sure we're doing things correctly? But that last mile of the ML prediction, the operation decision, it's a little bit less defined. It's very new. And so what a lot of teams do is they string together a set of existing tools in hopes of being able to tackle these problems. And a lot of times these tools are fantastic tools if they're used for their intended purpose. But if you try to repurpose existing tools, like to solve a new problem, they may not catch everything. And this is where ML observability comes in, that like last mile of you put the model in production, now what do we do? Just a definition for ML observability, it's the software that helps teams automatically monitor AI, understand how to fix it when it's broken, and ultimately improve your data and models. You might hear ML observability and ML monitoring used interchangeably, but ML monitoring is really just the tip of the iceberg. It's necessary. Everyone should have ML monitoring in play, but ML observability is the practice of actually finding out why an alert went off. So an alert happens. Why is that happening? How do I resolve this? And how do I really get that time to value? Again, sign up if you haven't already. This is the same link as the bit.ly link, same link that's being posted in the chat. Again, once you sign up for your Arize platform, we're going to be going through the hands-on workshop, and you have access to this afterwards. So you can play with the test data sets that are in the environment. You can upload your own data. So it's for you to use. And also join the Arize Slack community, because you can get your questions answered there, and just be able to, really see like what's the latest in ML observability. Yep, and the link's continuing to be posted. So Maggie's going to probably do it a few times. She's also going to post the link to join our Slack community, just to make sure everyone has that. And if anyone needs help signing up, just put it in the chat and we'll get to it. I'll still give everyone a few more minutes to sign up. Until then, we're going to kind of motivate a use case. So a fraud use case. So let's say that you are a machine learning engineer. You're working at a major bank, and you built a model to determine whether or not a customer's credit card transaction is fraudulent. Like, what happens if you don't monitor fraudulent transactions successfully? Like, what KPIs might suffer? So I have like a few prompting questions throughout this workshop. Me just talking for an hour, like why it's great. It's not always that much fun. So, if you have an idea of, what might happen if, your model makes too much fraud, doesn't catch enough fraud. Like, what are the things that suffer in this model? You don't have to have built a fraud model before, but just get you thinking on like what you want to keep in mind. You could just post it in the chat. If not, like, I probably will prompt, give like 30 seconds and then just move on. So like key kind of KPIs, if you don't know exactly like what you want to monitor for, like that's really where you have to start. You have to know like what you want to monitor for, what matters most to your team, where your team's losing money, where your company is losing money. All these things have to be thought of before you build the model. But once you build the model, you have to be careful about loss, and your losses are, in terms of like profitability, because if you have too much fraud, that's like that you're missing, you're going to have loss in profits from chargebacks. If you're constantly saying, like, every time a customer uses a card, like, oh, it's fraud, then you're going to have unsatisfied customers. So you may not be losing money to chargebacks, but you have an overwhelmed contact center, and it's just a lot to deal with in that time. Does anyone know like what metrics of success you might want to use for, like, if you're monitoring for fraudulent activities? So these are like more general, common metrics in, I guess I would say, in like statistics, like machine learning metrics, because some of the most common ones folks use, like, false positive rate, false negative rate, recall, precision. We're actually going to look at false negative rate today, and it's also called the miss rate. So the higher the rate, the more fraud slipping through. So you want a false negative rate to be 0, because if it's 1, you're letting all the fraud through. So we're going to transition now to the workshop part. So everyone that has signed up, you'll see like a kind of a welcome screen. And folks, if you haven't signed up yet, Maggie is still dropping the link so everyone has a chance to sign up. All right. Perfect. Can everyone see my screen? Great. I'm going to assume everyone can see my screen. If you have any questions along the way, just let me know. You can put them in the chat. If I don't see them right away, like someone on the Arize team will let me know. You could put in the Q&A. There will be time and I will pause for questions. But if it's something that I'm on right now, I really like it to be covered as soon as that question kind of comes up. So I mentioned that we're going to be talking about performance, data quality, drift and different types of drift, explainability, fairness, and bias. We'll try to get through all of those topics today. We may not. So whatever topic appears in the chat first is what we'll cover first. So if anyone has a specific topic from those that I mentioned, again, like performance, drift, data quality, explainability, fairness, and bias, like whoever puts it in the chat first, that's what we're going to cover first. All right, explainability. We got our first one. All right, so we're going to cover explainability and then types of drift. All right, awesome. Love the participation, folks. Okay, so we are, and I'm going to just put the chat box in the corner so I will be able to see questions as they come up. So we're going to be going through our fraud use case. So if you don't see this right away, you might be in like the quick start guide. The quick start guide's here, and it, on your own time, it could run you through each part. And yes, we will try to cover all sections. So like we will cover fairness and bias as well. And like, so this is the quick start guide. You could stop and start this whenever you like. You're going to see my face pop up and it's going to lead you through different parts. You'll also be able to sign up with me for like a 15-minute onboarding session if you get stuck along the way. Perfect. So let's go into our fraud use case. And we're going to actually set up our model first. So let's set up our model. We talked about having our false negative rate as the metric of choice. We're going to make the positive class or class we're identifying as frauds. We're going to identify fraud. We're going to turn on drift, data quality, and performance monitors. I'm not going to set up alerts right now, but you can do that. And then confirming, and now we're set up. And for drift, we actually have the option of doing automatic monitors, but we'll cover that when we get to the drift section. Okay, so the first part we got a question on is the explainability aspect. So I'm curious, just like yes or no, like how many people have used SHAP values? You can just put in the chat, yes or no. So SHAP values are a very popular way of using, okay, we got yeses and nos, that's great. So explainability often uses something called like a SHAP value, which SHAP values are rooted in game theory. And they're essentially trying to say like how important an individual feature is to an outcome. So explainability is different from performance, because performance, you have the ground truth back, you're using something like accuracy, and you're actually able to tell how well something's performing. But with explainability, it just tells you what features most strongly led to a particular decision. For example, if you're predicting, like the Pens will win the Stanley Cup, you predict that, I know they're already out, but you're predicting how many players like contribute to what, and you might say player A contributes this much, player B contributes this much. So it's just a way to like kind of triage your most important features. SHAP is the most common method used. There's a few other types, but it's a way of saying like, this is the most important feature. And there's different levels of explainability. So right now we're looking at feature importance here. We're looking at things like merchant ID, loan amount, home ownership, and seeing how important each feature plays into a classification of fraud or not fraud. So like a merchant ID is actually playing a large part in the prediction of if something is fraud or not. Now, again, this doesn't tell us if it's actually fraud. It just tells us what goes in the prediction so we can better understand our model. In the Arize platform, you can also add comparisons. Now, these could be different production environments, different versions of production environments, and you can also filter. Maybe you want to just look at a very particular feature, like FICO score, and you can look at something for like, one data set or another data set. So you can actually compare explainability values. And another important thing with explainability values is there's different levels of explainability. There's 3 levels to be exact. The first is local explainability. And so that's the local explainability of a single event. And that's for someone that, you're a financial company and you want to know like why this one individual was rejected for a loan. And so you're able to use SHAP values to say like, well, this was the most important feature that led to that decision. The next level is cohort level explainability, which is essentially like, I want to see, everyone that's in the state of California, like, I want to know like why things led to particular decisions there, or everyone like above the age of 30. I want to know information of what led to those decisions. So that's like cohort level. And then global is the most commonly used. Global explainability is essentially what you see here, where you're saying like, overall, this is the most important feature that has led to my decisions. And it's a great way to actually triage your feature importances. So if something's going weird with a feature, you can start with the most important one. We have a question in the chat. Do feature explanations differ between various labels? For example, predicting A, B, or C, which features led to a prediction of B? Yeah, so, and the way it's actually done for like a global level, so for local level, it varies a lot, right? Because you're looking at individual, like we said, like, individual people. So if each one of those decisions, you're trying to see what happens, it's going to be different for each person because it's going to be different inputs. And if it's global, like these are all the predictions averaged. So you're averaging and taking the absolute magnitude. So this is a great representation of your model overall. What's the third type of SHAP other than global and local? A cohort. So it's in between, so it's grouping, essentially, like, yeah. So in between level. Okay. Awesome. If there's any more questions on explainability, we'll see how this is actually used in practice, because explainability, I think, has been a buzz term lately. Like, it's something that's nice to have, but like the question of where does this actually come up when I'm practicing, and I'll show you like where it comes up. Claudia asked a great question, like, does this work for all types of models? That's very interesting, because for some types of models, it's not always practical. And the way you actually calculate SHAP for different models is different. Like there's tree-based SHAP for tree-based models. There's like a kernel-based SHAP. There's a like a neural network-based SHAP. So different architectures have a different type of SHAP value that's used. Do you have a list of explainability models that support? So for the Arize platform in particular, what's really great is, so with the Arize platform, and I'll show you actually how this looks. With the Arize platform, you don't actually upload the model itself. You upload the data that surrounds the model. So we have a few options. We use like a Python SDK, and these are our docs, just docs.arize.com. Maggie, can you link the docs in the chat as well? So if you want to continue playing around with Arize after the workshop, which I highly recommend, you can upload your own data, use the Arize docs, and it will show you exactly like the user guides, quick starts, like how to get your own data in. But going back to, we upload the data that surrounds your model. So you can calculate SHAP however you want, and then send those values into the Arize, because we're, an ML monitoring platform. So we're monitoring your inferences. So we're monitoring your models in production. So any versions of the models used in training, any versions that are, currently live, all that could be logged into the Arize platform. And then we just go kind of go from there. So you're going to upload the data, the features, you're going to upload your predictions, your actuals. Actuals, if you do have actuals, not everyone has actuals. Actuals are not for every use case, but you'll upload what you have, and then any SHAP values and metadata. We'll take all that into the platform and track it for you. What's nice is in the demo here is there's a few use cases where it's already uploaded for you, and all those collab notebooks are in the docs as well. Okay. Awesome. Great questions on explainability. Okay, so the next one we had was around drift. So for drift, being able to detect the different types of drift, let me make sure. Okay, so first in the Arize platform, so go to config, and you have to configure your model baseline before you can actually monitor for drift. And the reason this is the way we track for drift is monitoring two distributions against each other. So it's a comparison of two distributions. So you have a baseline distribution and you have like your current distribution. So there's always a reference and a current distribution. Normally folks will set their model baseline to be something pre-production, like a training set. But in the Arize platform, you can also say you retrain your model every week on like the last 60 days of data. You can have that set up. You can either do a fixed time range, a moving time range. So you can set up your baseline to be rolling or a training set. Most folks will use their training set. Sometimes that is a window on production, just so that they can compare what their model was trained on versus what they're actually seeing in production. So using a training version, you can upload multiple versions to Arize, and that's multiple versions of training, validation, production data sets. You can upload them all and compare them, which is really nice. So if I select a training version, I can click finish here. I also have it set currently for like auto drift monitors. We have a way of doing automatic monitors, so you can choose if you want that setting or not. You can also change out your drift evaluation time window, so the evaluation window over which drift is measured. So you can save this just as you like. We'll definitely keep the model. And yeah, I think that's what we want. Perfect. Okay. So now my drift, so now my drift monitors are set. So does anyone know like some different types of drift that you might see in production? There's various types of drift, and I will talk about them all. Data drift, concept drift, data label, concept. Wow, people are on it. Yeah, feature drift, perfect. Yeah, so folks really have a great understanding of the different types of drift. So the different types of drift that you'll encounter, and I'll definitely go through the ones mentioned. Prediction drift over time. So this is a drift in your predictions. A lot of people will just say like model drift or model decay, and that could mean anything. It's just saying that your model is now not performing as well as it had previously. So using like tracking for prediction drift is really important. And the nice thing about prediction drift, since it's looking at drift in predictions from like previous predictions, you don't need the actuals and you don't need the ground truths. So looking at prediction drift over time is really the best proxy for performance. Like if you have a use case where you might not get the actuals back for 30 days. If you're in insurance, you might never get those actuals back, or it will be years before you get those back. So being able to track for prediction drift is really key until you get those ground truths back. So that's prediction drift. Concept drift is another very popular form of drift. And that's when you're getting a drift in the independent variables. And what that means is there's drift in this brand new environment. A lot of concept drift happened during the pandemic, where models were trained, on a certain environment, and then the actual environment started to change. And looking at a drift in actuals, you do need actuals back in order to track for this drift, but it's very indicative of performance degradation. You can track it like exactly. So right now we have our false negative rate, we have it tracking over, and we're seeing that there's a spike in your false negative rate. Now remember, the higher the false negative rate, the more fraud is getting through, the worse it's performing. So being able to kind of look for this and see, okay, my performance is off as I'm getting more drift. I got a question on what metric do you use to quantify drift? Great question. So you might see people using KL divergence, Wasserstein distance. There's a lot of different ones because since you're measuring the difference in two distributions, there's a lot of ways to do it mathematically. What you'll see here is PSI, which is a population stability index. Arize has several blog posts on the topic, and this is what automatically propagates through the platform and how we automatically set alerts, because a population stability index is extremely stable. It's one of the few metrics that works for numeric and categorical features. So, different types of a feature set. It's derived from KL divergence. It's very popular in the finance industry, and it has this property of being symmetric. And what that means is it's very stable. And if you switch out, because like we said, we have the baseline and we have the current distribution. If you enter those into the equation, it doesn't matter if it's AB or BA, like you'll get the same result. But for other forms of measuring drift and other forms of measuring like that distance, it does depend on, which distribution comes first, which isn't always like the best method. KL divergence though, is the one I was the most familiar with. And it typically is used when there one distribution is a lot larger or smaller than another distribution. So actually in the Arize platform, if you go, let's go back into our fraud use case. Let's finish setting up our model actually, because what we did is we set our drift monitors this time. So now that we set our baseline, we have our drift monitors now. So we had to set that baseline in order to configure the rest of the monitors. And what's really nice is there's a setting, I don't know if it's already been rolled out or if it's rolling out this week, and it will automatically configure a baseline for you based on historic data. So that will be a really nice feature to have. So we have a few more questions. Okay, we got a question on, okay, why am I unable to choose false negative rate? Can you go to config and select false negative rate in your model baseline, Claudia? Test that out. And maybe Maggie can message you directly. Okay, perfect. All right, so if we go back now, if we go into our drift monitor with the Arize platform, if I click on individual monitors that have spiked, I can actually edit any monitor, and maybe I want to look for, I think of the chats blocking my view while editing. Okay, so yeah, the changes, since I have the automatic thresholds, so I could choose to keep it automatic, or I can change it all myself. If I choose to update and change it all myself, that's fine. That's just one option. So we're using drift as the default, but there'll soon be let's see, KL divergence and Wasserstein distance. Wasserstein distance, unlike KL divergence and PSI, is not a statistical property. So it's more of like almost like a physical metric, and it's like the amount of work that it takes to move one distribution into another distribution. I would say the key part is, choosing a metric that's robust to drift, which PSI is the most robust to drift, is the most, I think it's pretty much the most well researched when you see like what teams are using. Also seeing some more questions in the chat. So that's a lot on drift. Last thing we will cover data drift as well, but I'm going to answer a few of these questions in the chat. Is Arize available on-prem deployment? It's available on-prem and SaaS. Yeah, so both options there. Is there any limitation to the data size to upload to this UI? Yes, if you go on the Arize website, one of the top panels says pricing. And I think it's 2 models. You can upload 2 models, and I think it's up to 500,000 inferences a month. So there is like a volume limit, but you can erase old models and put on new models. Thanks, Maggie. Maggie just replied in the chat. So you have that. I also see a Q&A. Can you define a time window for calculating drift? Yes. So let's go back to our fraud use case. Let's go into drift. So right now my drift evaluation time window is 72 hours. If I want to reconfigure this, I can change my evaluation time window to like the following settings here. So you're able to do that. Perfect. Okay. So let's get back to the last type of drift, and then we still have folks that want to see the fairness and bias and performance. And I think we'll have time to get to all of them. So that will be great. So in terms of data drift, which was what a lot of folks typed in. So data drift it's feature drift, it's input drift, it's any dependent variable that starts to drift is going to be data drift, and that can be kind of like a subclass of model decay. If someone's like, yeah, my model is drifting, could be data, could be concept, and it could also be something that I call upstream drift, where upstream drift is like, say you trained your model on only like capitalized states, and now all of a sudden uncapitalized states are starting to come in. And so it's drifting, feature will start drifting based on changes like in the actual like type of either like the data type or what that data looks like. So for feature drift here, we're now looking at the feature name, the prediction drift impact score, the feature importance, and drift. So we already covered like what is drift, how is it calculated? So drift is our PSI score. Here's our feature importance. And so we can, choose to triage and like rank our features by feature importance. And if you multiply your feature importance by your drift, so PSI again is population stability index. We also have a few blog posts on that, and it's in our docs, just like our docs.arize.com sections on it there. So population stability index, very robust type of drift measurement. So the higher the PSI score, the more drift. And in fact, if like it's a statistical anomaly, like meaning it's, it is indicative of a change in the population if a PSI score is above 0.2. So anything above 0.2 means it's very likely that there is a type of drift occurring. So you could rank something by, the actual PSI score. So you can say like, okay, my model is drifting, because right now we see that, there's very much drift that is highlighted. We have our monitor set for 0.25, and there's a lot of drift occurring. We have another question. What if you had a PSI score of 0.277 and is it indicated in red? Yes. So, right now we have this dot. Let's see, what's the lower dot? Yeah, this dot. So right now our mark is at 0.25. That's just what we had set our monitors on. And yes, if you have something that's 0.277, there's a lot of drift occurring. You might want to see like why that is, what's happening there. And you would get an alert for that as long as your monitors are set above 0.27, you would get an alert for that. Now there's some features that folks will like not have their monitors set on, for example, like user IDs. User IDs always drift because there's always more added, but that's just a feature of like, oh, I have a drift of 7, but it's not one that you actually need to care about, whereas something like state, most other features you have to care about drift, but something like user ID is an example of one that will drift a lot, but that won't be indicative of if your model's underperforming. Another question. Is the data you see in the dashboard available programmatically so you can automate tasks such as retraining based on it? Great question, Joshua. So with the Arize platform, like those alerts that you saw, we also integrate with tools like Amazon EventBridge, which are used to trigger a retraining cycle. So once you have, your monitor set and you have them set, so if a given alert goes off, you want your model to be retrained, you can set that up. So things can trigger retraining cycle. You can also like in our dashboards, and I'll get to dashboards probably at the end, you can export all that data that you're looking at. Like we normally use Arize to focus down on a particular cause, and then teams can like export that particular set that has funky stuff going on. All right, another question. What about adjusting the scales for time? And can you include, and can you get higher density of data points, data changes and data drift over, okay, hold on one sec. Scales for time. Higher density of data points. Oh, okay. Okay, so, so one thing we do, that's a great question, is we always plot volume or traffic, or I guess you could say like density in this case. So we always plot the traffic or volume in our plots as well. So this is like if there's a big spike in data, you can also just zoom in on particular sets. Like you're seeing like this is the date. You can set like that date, that time period of that significant spike, and really focus in on it. You can also see it all through our data ingestion tab. So like similar to Datadog, like just being able to find like where the data is, like where is it going, like how much is coming in, because we track for data quality, percent empties. So making sure that you can see all that data, because what you said, like if there's a high density of data, a lot of things could be going on with that. We see high density of data and like bot attacks on sites. So being able to track for that. Okay, a few more questions. Besides the model, do we need to upload the trainer test or anything like that? So you don't upload the model. Actually, so the way it looks is the data, the features, the predictions and actuals. So this is what you need to track for performance, or to track for performance, drift, and data quality. Again, you might not have these actuals back. So the only thing you actually need is you need the inputs, you need what goes in, and the predictions. And then we could take SHAP values, we could take your actuals, we could take parts on your model, but you don't have to upload any training or validation sets. A lot of teams do because they can compare them in the platform. We'll see that when we get to performance next, and we do version control. So you can like send in as many versions of the model as you want, A/B test and compare them. And it's really nice to be able to see that, but you don't actually have to upload the test and train. You can use a window on that production set as your baseline, because you do need to set up a baseline if you want to look at drift. All right, and we have another question in the Q&A, and yeah, you guys can ask it in the chat, in the Q&A. Is the number and I'll answer this one live. Is the number for prediction drift impact higher means the worse the model will perform? Yes. And let's go back to like what that looks like. So I said we have this prediction drift impact score. So this is essentially multiplying your feature importance by your drift. So we talked about feature importance, like what is the most important feature to your model. We talked about that with explainability. So the higher the feature importance, the more important the feature. The higher the drift, the more that individual feature is drifting. So we multiply these together to get a prediction drift impact score for teams to look at, not just what is drifting the most, but what's the most important feature that's drifting. Because there may be a feature that like barely plays any role in your model prediction that's drifting a lot. And so maybe that's not as important because even if you fix it, it's not going to really change much. But if you fix an important feature that's drifting, that's pretty key. Like if we look at something and we go and we check out state and we see state drifting a lot, we can see the PSI, and this is for the individual like state. So we can look and see like now all of a sudden, we're just really getting only a few states. And like we've trained on a lot more. We can also have an overview of data quality and see that the cardinality has shifted, just as an extra add for like what we're able to see. Okay, so that pretty much covers drift. When drift monitors go off, being able to see like, what we can tell here. Maybe we see, it's another feature that, let's look at a feature that has a decent amount of drift. Let's go to our drift tab. Let's see, high PSI score, merchant risk score. Okay, we see a lot of drift right here. Let's see here. And as we're looking, kind of clicking through, we see, particular bins or distributions that have a high spike. So being able to, see where within the data something like this is happening and be able to do quick data quality checks as well. Now I'm in more of an exploratory mode. A lot of folks will set it up just to get the monitor and alerts and then being able to go in and troubleshoot each part. All right, got some more questions here. Does Arize work with images, object detection, for example? Great question. Actually, the beginning of next month, beginning of June, we are releasing our embeddings capabilities. And so that's for like image classification, text classification, so like NLP, computer vision use cases. So you'll actually be able to track embedding drift for those features. And you can also track embedding drift for regression, regression and classification examples as well. So we will have that capability, which is really exciting. And we will be having an event next month where like leaders in the NLP and computer vision space are going to be talking about use cases and embeddings. OpenAI, Hugging Face are all going to be there too. Can you integrate Arize with other API dashboards like Grafana? Yes. So if you go into our Arize page, you can see like our integrations. So like our ML platform integrations, have a lot there, and monitoring integrations as well. Interesting that you mentioned Grafana because our dashboards, which I'll show kind of after performance and fairness, are actually very, very similar to Grafana. How do you simulate drift and CI/CD testing before ML model deployment? That's a good question. And you probably would need a historic data set. Like, so if you're simulating drift, you'd probably need to know like how that might look. And normally that's done by like either using historic data, previous models, or putting like one like challenger model in production, or like one testing model where it's, not making all these decisions, but making some just to get that feedback. Otherwise, there are data sets, like we manipulate the data sets like based on like what we see happening in the industry to show you guys drift in the platform. yeah, so that's a few ways. And that's why it's also important to have an ML observability system in play, so that when you do put a model into production, you have these alerts already set up so that you can resolve issues straight away. Is there a limit of data that we can upload? Yes. Maggie put a link to pricing for the free tier. Like if you're out of the free tier, it's like infinite. We have teams doing, we have ad tech teams doing billions of predictions, way more than that, like billions per second. I'm not on like the backend side, but like scale's the main, one of our main factors that we are keen on supporting. So there is, I think it's 500,000 inferences for the free model. Can it be integrated to other tools, alerting tools? Yes, we may not, if there's some monitoring like integration or platform integration you don't see, like the Arize team, we have all those just because they were highly requested. We just will build them. We'll build different integration tools. The nice thing with the Arize platform, since you just have to send the data surrounding the model, things integrate very well with our system. So we build those a lot of the times. And okay, we got several questions on like putting the link to the NLP event. Awesome. Thanks, Maggie. So Maggie just also posted the link to our upcoming events. Make sure you follow this page. In fact, so what I'm doing today is like an overall workshop on the platform. We're actually creating like a certification series. So there will be a workshop series on each pillar of ML observability. It will be with the Arize platform. It's with me. It starts next week, and there are live 30-minute sessions. It's 7 weeks of these live sessions, and each category that I talked about, including embeddings training, will also be on there. So definitely sign up for this workshop series. You already have like your platform, you already have like your own account, and we'll go into like every aspect and play around with the data there. Integration with Google Cloud. Yes. So the way you get data into Arize, we have a Python SDK option, which is probably the most used option. And then we have a file importer option. So like AWS, GCP. Yes. Okay. Awesome. I think I have a few more questions in the Q&A. Awesome questions, folks. Like this is like one of the most engaged workshops I've had in a while. And it's awesome that's remote. Okay, we saw integrations with Neptune and weights and biases. Are you planning to do one with Comet too? Maggie, maybe put that down. We always are looking for more partners. These are just folks, that have come up. But yeah, like we'd love to do more events. We actually have 2 different meetups coming up, one at the end of next month and one at the end of July, one with mParticle, one with weights and biases. So yeah, we love collaborating. I don't know if I could say like we're a really cool group. I think so. And yeah, we just, we want to provide a lot of educational material. We want, everyone to be like comfortable in the space. So yeah, like that would be awesome. If you know someone, Andrew, send us a message and we'll make that happen. Okay. Yeah. Daniel's already in the platform. He's ready to go. So we're going to answer this one live. We want to make sure we could get to like a few other areas. You guys are awesome. Thank you. Yeah. Compliments are always welcome. Like, especially you work from home. It's great to have all these interactions. And these questions have been awesome. So let's get into performance tracing. Performance tracing is really cool because performance tracing is patented by Arize. So, you can have like performance metrics, but Arize is the only tool that does performance tracing. And let me show you what I mean. So you can look at your performance over time, again, tracking the volume. Here, for example, is a volume spike. So, going back to maybe we wanted to look at that traffic because it looks pretty strange. You can have some information like fusion matrices, calibration charts, But what's really key here is the performance breakdown at the slice level. And when I say slice, I mean individual points of data. So you selected your metric, false negative rate. We know like what's the best, 0 is the best, 1's the worst. And now we have an actual breakdown at the feature level, at the input level. So we still have our feature importances, so our explainability, but we have our performance impact as well. And this performance impact score is a slice feature value impact on overall model performance. So the way this is calculated is I'm looking at, my overall performance, and this is based on this window that I've selected. And I'm calculating the delta between each slice for numeric input for categorical, that delta as a function of volume for what's going to bring up my performance the most. So this is going to rank the worst performing slice of data over my entire platform. So if something's performing poorly, like it's going to tell me exactly where it is. And what folks tend to do a lot is add comparisons again. So again, I'm able to do one-to-one comparisons. And, I could do a production environment. I could do a different time window. I could do different versions of productions. There's a lot of choices. You can have your cake and eat it too. So you can choose production versions, you could choose different validation sets, different versions of validation sets, validation versus training sets. So I think version control is really important to be able to look at in your models. We also do model comparisons as well, but a lot of teams really want this version control for their models. So if I make this second part here, this false negative rate, if this is what I see in training, so this is a bit better than what I see overall. But what's really bad is what's happening right here. So if I want to just kind of focus in on this, one part, I can focus in on that. And now we see the false negative rates about like 90%. So, we said 1 is the worst you can get. So this is pretty bad, especially compared to our training. So we have performance, that's really bad right here. We don't know why. So let's go down and actually look at how our distributions look. So you saw we had, a distribution before. Now we have mirrored distributions, which are, color coded, anything yellow or more white is performing very well. And this goes for any metric. You could change out any metric and it's going to tell you based on a gradient how it's performing. And so I can go down, I can rank and triage and just be able to see, where my model is performing well, where it's performing poorly, and it's consistently performing. We could say it's consistently performing worse for, that one individual area, but trying to figure out, like why is this the case? What's happening here? And if something is the same distribution, it might not mean that there's a problem, but something's a completely different distribution that tends to be like just like a bird's eye view of like something's like really wrong here. So if we go into an individual feature, now we have a side-by-side comparison at the slice level over volume percentage with a gradient score. So it's a lot of information, but it's supposed to be like an overall bird's eye view for what you can see. It really just like eliminates a lot of like, 100 SQL queries and like not knowing where to start with that. So what we see really is high volume for this one merchant here. A lot of impact. So what I can now choose to do is I can select this feature. I can add it as a range, add it as a filter, and I can actually like add filters to these individual ones. I could do it manually or do it by just like selecting one. So for example, maybe I see something like lease is performing really poorly. I can choose to add it as a filter or exclude it as a cohort. And then if I exclude it as a cohort, I'll be able to see how it actually improves the performance of each set. And you can continue to do this throughout. We had another question on what performance is this for data set. So what performance is this data sets? I think it's, I think you mean like it's the false negative rate, and I'm comparing a production data set with a training set. And I'm just selecting all versions. So we only have a few minutes left. And so that's just an example of performance tracing, like being able to diagnose exactly like where there's problems and what could bring up your performance the most. So if we dive in deeper, and I encourage everyone to try this on their own, you could start like excluding features, like excluding really bad performing inputs, and see if you can bring up the performance of this one individual slice, because that's normally where you want to start with your data set. Unfortunately, we didn't get fairness and bias, but it's very similar to that performance tracing workflow. You can select what attribute you're looking at. You could select a base. You could select a sensitive group and do that comparison. And then you'll get recall parity, and then you'll have the whole breakdown as well, similar to what you did with performance tracing. Okay, so that's a lot. It looks like everyone was, pretty involved, a lot of great questions. And, sign up for that workshop series, because, we didn't cover really like data quality. We didn't really get to go into fairness, and we didn't get to like really troubleshoot performance tracing. So that workshop, it's 7 weeks, but it's only like 30 minutes a week. And those are going to be live sessions where we go through and we really focus on individual parts. And there'll also be the NLP capabilities, those embeddings as well. Thanks everyone for participating. Yeah, you all killed it. Props to those where it's midnight right now and you're still asking questions. This was a really fun session. Yeah, definitely join the community, keep up with what we're doing. You are all fantastic, and I'm looking forward to seeing you at future events. I'm going to stop the screen share now, and I hope everyone has a great night.